Welcome back. We just finished finding our two x-intercepts, so now we need to find our local min and local max. So looking at our graph right away, we will have two local mins, these 2 points right here, and we are going to have one local max, which is going to be that point up there. So let's go through and try to find those points. So for D, local min, and then we'll have our local max. So we're going to have two local min, and you know that because we have two lower points of our graph. And so to find our local min, we're just going to find the minimum value of this drop in our graph here. So this is just like finding the minimum of value of a parabola, so like our vertex, like we did in previous units. So looking at our calculator, we're going to go to second trace and go for our minimum, which is option number 3. And let's move our cursor all the way over to our further left minimum point, okay? So if we're looking at what our calculator says, it wants us to get left bound, so a little bit left of the minimum point, so we hit enter. Then it wants us to find right bound, move the cursor to the right, and then we can hit enter, and then guess, just move the cursor towards the minimum point, hit enter again, and this gives us our point of negative 2.24, comma, negative 6.53. All right, so that is one of our local min. So I'll write that down here, negative 2.24, comma, negative 6.53. All right, now we have to find this other local min, so let's do second trace again. Option number 3 for a minimum. Go all the way over. So the left side of our minimum value, we hit enter. Now we need to go to the right side. Hit enter again. Move the cursor a little bit towards the minimum value there. Hit enter. And this gives us our other point of not negative 1.58 or 1.59, either one, comma, negative 25.8. 82, we could say. All right, so that gives us a point of 1.58, comma, negative 25.82. So both of these are local min, but actually this point here is a local min, but it's also an absolute min as well, because this is the lowest point of the entire graph. So this point right here is an absolute min. Okay, it only asks us for a local min, that's why we had to list both. But if it asks us for our absolute min, we would have to list this point here. All right, now to find our local max, we do the same thing, second trace, but we're going to go for option number 4 for our maximum. We're going to move our cursor over so it's on the left side of our maximum point. Then we hit enter, then we move it on over to the right side, hit enter again, then move the cursor towards the maximum point and hit enter for a third time. This gives us the point of negative 0.84, comma, negative 0.84. Okay, so that's our local max. We'll write this up here, local max. Be sure to label all of these things on our graph in order to get full points, just so I know that you know what all of these points are, okay? So that is essentially it for this. I want you to try, based off of what we did for example 1, to go through example 2 on your own and see and compare with what I have to see how you did. So pause the video and then check your work. Welcome back. So looking at your graph, it should look something like this. If it doesn't look something like this, it's probably because you didn't change your window of your graph back to standard form. Because remember, we changed it for our first graph to have a y value of -30. So make sure that your window is in standard form. Okay, so it should look something like this, or I have it over here as well. So if you not have all this information, make sure that you go through and make the corrections necessary, okay? So first step is to sketch your graph, and then from there you need to find your end behavior. So as x goes to positive infinity, our y value, that is going to negative infinity, okay? And if we have our f of x, if that's going to positive infinity, then our x value is going to negative infinity, okay? And these are different, unlike this one, because our coefficient in front of our largest exponent is negative, so it's changing what we would normally think our end behavior would be. Okay, then to find our zeros, we'll use our zero function on our calculator. Remember to find that. It's trace, or second trace, and it's the second option here. Okay, you do that, find all of those zeros, each of those points. And then to find your local min, remember that's just using the min function on your calculator. So again, to get to that point, you go to second trace, and you use this minimum value here. That will give you this point here. And then to find your local max, you use your maximum function to get that point. Now both of these are local min and local max because on this graph there's a lower point than this local min that goes down to negative infinity. And this is a local max. There is no absolute max because this continues to grow onto positive infinity. Okay, so these are just a local min and a local max. And if you wanted to double check, since our degree is 3, our n is 3, if you want to make a note, so n is 3, so that means we're going to have 2 turning points at most. And this graph does it. If we start at the furthest left side, we're going, and all of a sudden, we take a turn, and that turn is our local min, it's our lowest point there. And then we keep going, so it's one turn, keep going up, up, up. Oh, and then we turn again at our local max there, and then we just continue to go down. So those are our 2 turning points, and that gives us one local min and one local max. Okay, so this concludes our video for 6.8. If you have any questions, please bring them to class and we can go over it. All right, have a good night.